In this lesson, I'm going to demonstrate how to handle exceptions within Visual Basic.net. If you haven't already done this, please take the time to read the lesson text for Lesson 21 in the workbook. It contains preliminary information that you're going to need to know that we're not going to cover in this video. To demonstrate how to handle exceptions in Visual Basic.net, I've created a simple Windows Forms application called Lesson 21 in my Begin 1 directory. Then I simply added two text boxes, txt number 1, txt number 2, and a button called btn calculate. And the calculate button will multiply together the values in each of the text boxes and show that in a message box. So let's go ahead and run our application, try to break it right away by typing in letters instead of numbers. Immediately we'll get a message from VisualStudio.net that tells us we have an exception of type invalid cast exception. Now in the lesson text we talked about all the many different kinds of exceptions that exist. There's dozens if not hundreds of different exceptions that are strongly typed within the .NET framework. And these are provided so that we can determine exactly what happened within our application and test using the try-catch statement, test to see which type of exception occurred and then potentially handle each of those cases differently. So let's go ahead and just click on the continue button here to stop the application. Notice that since we didn't handle the exception, the runtime had to catch the exception and it didn't allow the application to continue to execute. It ended the application immediately. Obviously this is not the type of functionality we want to enable whenever our users are using our application and an exception occurs, the whole program blows up, and they begin to see your product in a different light, in a very unstable, unprofessional piece of software that they're currently working with, and obviously we don't want that. So let's add another button. I'm just going to leave the default name to button 1. Let's add some new code here. In fact, let's go ahead and copy the code from here to show what changes we can make to make this slightly more stable. What we'll do is begin with a try statement and a catch statement, ex as exception. Then let's take these values and put them in the try, and in the catch, let me paste in some code. So essentially what we'll do is add some structured exception handling in the form of our try, catch, and try statement to seek out any problems that can occur from the calculation of txt number 1 and txt number 2 text fields. If something bad does happen, we're going to use a catch-all, and we notice that all exceptions are based on the exception base class, so we can just catch this, and although it'll be specifically a invalid cast exception, this will still catch that exception here since it's a more general form of that exception. If that happens, then we'll display a message box to the user saying there's a problem with your entry. Please make sure you enter numeric values only. Much more friendlier way. And then let's also see what happens after this exception occurs, as opposed to the last time we ran the app. So here again, we'll type in some junk into our user interface, and this time we'll click button 1. And we have a message box. It looks kind of and sounded rather threatening, but it's one of our own creation, that there was a problem with your entry. Please make sure you enter numeric values only. Then it continues on with the application. So by doing this, by adding our structured exception handling, we were able to greatly improve the stability of our app. So this is all well and good with a very simple application, but let's see what happens When we create an application with multiple tiers, and we'll talk about how the exceptions can be bubbled up to another layer in the software. So to accomplish this, I'm going to add a new component because it'll give us a visual interface. And that component I'm going to call Northwind. And we'll just make it very simple. It will have a connection to our Northwind database. So let's just change the name of this to con. And then I'm going to create one public method for this class. And I'm just going to paste in some code that I've got here. Let's talk this over just for a moment. I have a public sub open, which essentially opens a connection to the database. Now, what I'm going to do to kind of thwart this method and raise an exception is to change the connection string just a little bit, ever so slightly, so that it will fail. And the way I'm going to do this is change the name of the database to, and just add a 2 in the name. So there is no database by that name. Now, what will happen is there will be an exception raised. And we are going to capture that exception, or catch that exception, in the following way. So we're going to try to open the connection. We anticipate that if there is a problem, it will be a problem OLEDB exception. And like we talked about in the lesson text, we always want to catch the most specific types of exceptions first. What we'll also do is catch, I'll just add some more code here, catch EX as just exception, and then we'll throw new exception unknown problem with database. So at least we capture something if it is not our OLEDB exception. So we go from the most specific to the most generic with our catch statements within our try-catch. Additionally, we have the option of either handling this problem internally if possible. So is there anything that I can do internally to this class, or this method rather, that could fix the problem? Can I try the connection a second time, a third time? Yeah, I certainly could write code to do all that. And if it continues to have a problem, then raise the exception. Or I could throw this exact exception, the OLEDB exception, back to the caller and let it handle the problem. Or I can throw a new exception and let the handler call that problem. Now what I've chose to do is just throw a general exception and pass in the specific error message that I want displayed back to the end user. I'm not going to put a message box here. That wouldn't be a good idea. We don't want to mix the user interface in with the business classes, but what I can do is put some type of explanation as to why this exception occurred. So now let's go to our Form 1 and add another button. Whoops, let's get to our toolbox here. And we'll just leave it the default name. Now the way that I've constructed my application, the first thing I want to do is dim n as new Northwind, and then let's do n.open. Now what happens if n.open fails? Well, it'll fail in our Northwind class, but if it fails in the Northwind class, it's going to raise a new exception and throw it up. So we still need to catch it here in our Form 1. So when you think about exception handling, you have to think about it in terms of layers. Each layer should have its own wrapper of try-catches that anticipate anything that can go wrong. Now the question might come up, when do I need to use exception handling? Notice that there's some things that I'll do. Here, let me finish this first thought. Let's try this. Try catch EX as exception. So we'll put our n open statement here, and then we'll just do this message box.show ex.message. Okay, so here we go. Now you might ask yourself, well, what should I wrap try catches around, and what should I just leave alone? And generally, like for example here, notice that I don't have a try catch around this information. Well, you should write, I think, in my opinion, try catches around anything where there's potential for failure. There's a very low likelihood that you're going to fail on this type of statement. However, connecting to a database is something that it has been known to fail quite often in the past. So with a little bit of experience and a little bit of forethought, you can think, what are the loosest or the weakest links in the chain? And wherever you determine those weak points are within your application, you should wrap some structured exception handling around that. And database access definitely falls under a weak link in the chain. If the database gets renamed, or whenever you're dealing with SQL Server, if the connection between the servers gets broken somehow, or whatever the case might be, that would cause a problem for the entire application. And we want this to respond well to problems. So the next question is, why did I choose to display a message box to show the message to the end user? Here, why didn't I just throw it again? Well, at some level you're going to have to handle the exception, or if you don't handle it, we've already seen what the consequences are. It gets passed back all the way up to the framework, and the framework will handle the exception and shut down your program. So the best place to do this, to actually handle the exception, is in the user interface, where it's going to have the final say in how to display that to the user and request the user's input on how to proceed. In this case, we're just simply going to show the user what the problem was, but we could very well give them some options, like you can click yes to try this again, click no to stop attempting to do this, or click cancel to forget we've ever tried this, or whatever the case might be. So let's see how our application responds now. We're going to click button 2, and we get a problem opening database. Notice that that is a specific exception that we got. We didn't get the more general unknown problem because we anticipated that the problem whatever problem might happen in terms of working with an OLEDB database, that is probably a connection problem. So that's why we displayed this exception. We might want to use a finally statement as well if this particular operation succeeds and we have another method on our class that executes a query. We'll need to first open up a connection to the database. If that succeeds, then we may need to have a different set of try catches to ensure that the query gets performed properly. And if it doesn't, we'd want to use a finally statement like so, and to make sure that it closes the connection to the database regardless of whether our query succeeds or fails. So we're not going to do this here in this case, but keep in mind that that's the use of the finally statement. Just a few more notes before we conclude. It is true that the more try catches you use within your application, the slower it gets. However, let me say this, that in most cases you're not going to be writing applications that require a high degree of speed unless you're creating an application for one of the top 100 companies within the world who do e-commerce. And what would you rather have? A slightly slower application that always performs and gives proper feedback to the user, or one that can just come to a screeching halt if a problem does arise? I would prefer the former. That's a decision that you'll have to make on what level of it that you're willing to accept. Finally, I'd like to really encourage you to do the exercise for lesson 21. It's not a code exercise. This time it's a going through and looking up all the exceptions that you can possibly find the help. Just become familiar with what exceptions are available to you so that you can catch the most specific ones first and then generalize as you work through your try-catch statements. Believe me, this will be a valuable exercise. I gained a lot of insight once I tried to do this, so I encourage you to do it. It will be time consuming and a little bit painful. There will not be a video to demonstrate how to do this, by the way. So, good luck. Thank you.